Hello class, this week we're going to take a look at the independent samples t-test. Last week we did paired samples, and take a look at the independent this week. And so we'll use the same data set. Remember the paired samples t-test, we were comparing the pretest and midterm scores and pretest and final scores for this overall group. In the independent samples t-test, we take a look and segment folks into different groups. And one of the ways we could do that here is, let's say we wanted to compare differences between gender, males and females, for, let's say, pretest scores. And so that would be an independent samples t-test. So if we go up to Analyze, Compare Means, Independent samples t-test, we could take a look at the pretest scores based on gender. And when we're asked to define the group, we're going to have to type in the male and female, just how it's listed in the data there. Now when we run this, you'll notice the females do have a slightly higher mean than the males, 63.62 over 61.67. But the key is we want to look at that significance and see if it's below the 0.05 level, see if it's actually significant. And if we look here, we see 0.456. So this is actually not statistically significant. In other words, there's not a significant difference between males and females. And that's kind of what we'd expect, because gender, there's nothing really in that would lead us to believe there would be a difference in test scores. This can be applied in other areas where if you compare groups, sometimes there'll be a statistically significant difference, of course, sometimes not. And so what you want to do is, in comparing that, always look for the significant difference, just like you did in the paired samples t-test. Remembering that the difference here is you have two groups. We're segmenting, in this case, by gender, male and female. And so this is the independent samples t-test.